Imagine for a second you come home after a long weekend away, you walk into your living room, drop your bags, and you just realize something is off.
Yeah.
There's a stranger on your couch. But they're not just crashing there. They've like rewired your entire electrical box to run some massive factory in your basement.
Right.
They've set up a toll booth on your front porch and they're charging your neighbors to walk by, and they've changed the locks, only they have the keys now.
That is a terrifying image, isn't it? But honestly, it's probably the most accurate analogy I can think of for what we're unpacking today.
Really?
Yeah. We're not just talking about a digital break-in.
Yeah.
This is a parasite that doesn't just infect a host. It renovates the house and moves in for good.
Renovates the house while you're still paying the mortgage. So welcome back to the deep dive. Today we're looking at a report from the Hacker News. It's dated February 9, 2026, and it covers some really extensive research by the security firm Flare. It's all about a threat group they're calling TeamPCP. And I have to say, looking at the scale of this thing, I was genuinely shocked.
It is shocking. And what makes TeamPCP so interesting and, frankly so dangerous is that they represent this shift in how we have to think about cybercrime. We usually picture hackers as, these lone wolves, right?
The guy in the hoodie in a dark room, furiously typing green code on a black screen.
Exactly. But TeamPCP isn't that. They are what happens when cybercrime gets industrialized. They haven't just built a tool, they've built a self-sustaining ecosystem. It's like they've applied the principles of factory automation to hacking.
Industrialized cybercrime. I mean, that sounds incredibly ominous. It sounds like something from a sci-fi dystopian novel.
It does, but the timeline shows it's very, very real. This campaign really kicked into high gear around December 25, 2025.
Ah, Christmas Day. Of course.
That's a classic tactic. They know IT security teams are running on skeleton crews. While the defenders are home with their families, eating and opening presents, the attackers are deploying worms. The research shows they had chatter on Telegram going back to July 2025 and some active hacking in November. But that massive worm-driven explosion, it was timed perfectly for the holidays.
That is just ruthless. It was actually first documented by a researcher named Beelzebub under the name Operation PCPcat. And before we get into the technical nightmare fuel here, we have to address the branding. TeamPCP, DeadCatx3, PCPcat.
The naming conventions in the cyber underground are always this bizarre mix of trying to sound edgy and just being absurd. You've got aliases like PCPcat and ShellForce.
Right.
But you can't let the silly names fool you. I mean, DeadCatx3 might sound like a bad grunge band, but they're operating a Telegram channel with over 700 members.
700 members. That's not a small crew. That's a small army.
It's a community, and they use that channel like a portfolio. They're posting stolen data from victims in Canada, Serbia, South Korea, the UAE, and the US.
That geographic spread is just wild to me. Usually when we look at these reports, you see a pattern. State-sponsored actors targeting American finance or criminals heading European healthcare. This looks completely random. Why Serbia and Canada?
Because it is random. And that is such a crucial distinction for everyone listening to understand. TeamPCP isn't a sniper. They are a trawler net.
Okay.
They aren't targeting a specific industry. They are targeting infrastructure, specifically Amazon Web Services, AWS, and Microsoft Azure.
So if you're a shoe store in Ohio using AWS, you're just as much of a target as some big tech firm in Seoul.
Exactly. The report even refers to the victims as collateral. They do not care who you are. They care that you have compute power and bandwidth. They're rattling every doorknob on the internet, and if yours is unlocked, they move in. It doesn't matter if you're a hospital or a hobbyist blog.
That's almost scarier than a targeted attack. You can't just say, oh, nobody would want to hack me. I'm boring.
Precisely. To them, you aren't a person or a company. You are a resource.
Okay, so let's talk about how they get in. The report describes this as a worm-driven campaign. I feel like worm is a term people hear, but maybe they conflate it with virus. What's the functional difference here?
Think of a standard virus like a biological flu. It usually needs a carrier. It needs you to make a mistake, like clicking a bad link or downloading an infected file to start the infection. A worm is different. A worm is autonomous.
So it drives itself.
It's like a robot that walks into a room, copies itself, and then those copies walk into the next rooms. It propagates without any human interaction. Once it infects one server, it automatically scans the network for others, copies itself over, and just repeats the process.
So it's hunting on autopilot. What specifically is it hunting for?
In this case, it's hunting for what we call cloud-native environments.
Cloud native, we hear that a lot in tech marketing. Go cloud native.
Yeah.
But in this context, what are they actually looking for?
They're looking for the machinery that runs modern applications. So things like exposed Docker APIs, Kubernetes clusters, Ray dashboards, Redis servers.
Right. To clarify for anyone who doesn't spend their day in the terminal, Docker and Kubernetes are basically the shipping containers of the software world, yeah.
That's a great way to put it. They're tools used to package and run software really efficiently. But here's the problem. Developers often configure them for ease of use, not for security. They might leave an API open so they can access it from home or something.
Okay.
TeamPCP's worm scans the entire internet, looking for those specific open ports.
It's like leaving the loading dock door wide open. But they aren't just looking for misconfigurations, are they? The report mentions a specific vulnerability that sounds pretty nasty. React to shell.
Yes, CVE 2025-551A2. This is a vulnerability in React and Next.js applications. And this is where it gets really serious. The CVSS score, the Common Vulnerability Scoring System, is a 10.0.
That's the max score, a 10. That's the top of the scale.
It is the game over score. A 10.0 usually means remote code execution without any authentication. It means the attacker doesn't need a password. They just send the specific command and the server obeys.
So if I have this vulnerability, they don't need to guess my password or phish my employees. They just walk right in.
They walk in and they own the place instantly.
Okay, so they're in. The worm has crawled into the server. Now, this is where I want to get into that industrialization aspect you mentioned earlier. Because looking at the scripts they use, it feels like an assembly line.
It really is. The Flare research team broke down the toolkit, and what's so interesting is that TeamPCP isn't using some, never-before-seen spy movie technology. They are using tried and tested techniques, but they have automated them to a level of efficiency that is, frankly, impressive.
Let's look at the Scout, the file name of proxy.sh.
Proxy.sh is a fascinating piece of code because it's context-aware.
Context-aware, it knows where it is.
Exactly. When proxy.sh lands on a victim's machine, it performs what we call environment fingerprinting. It looks around and asks, am I on a standard Linux server? Or am I inside a Kubernetes cluster?
And why does that distinction matter to the malware?
Because the tools you use to exploit a standard server are different from the tools you need for a Kubernetes cluster. If the script detects it's in Kubernetes, it just branches its logic. It switches to a whole different execution path and drops a cluster-specific payload.
That is frighteningly smart. It's like a burglar realizing, oh, I'm in a bank vault, not a house, and instantly swapping a crowbar for a thermal drill.
And it all happens in milliseconds. While it's doing that, it's also installing proxy and tunneling utilities. It basically turns your server into a relay point so they can route traffic through you, hiding their location for future attacks.
So that's the Scout. Then there's the hunter.scanner.py.
Right. Scanner.py is the engine that keeps the worm moving. It scans for those exposed Docker APIs and Ray dashboards we talked about. But there is a detail here that just really shows their audacity. Where do you think it gets its list of targets from?
I don't know. Usually these things have a built-in list, or they just generate random IPs.
Not this one. It downloads its target lists, these are called CIDR lists, directly from a GitHub account.
Wait, GitHub, the legitimate code hosting site where every developer puts their projects.
The very same one, an account named DeadCatx3. They're hosting their hit lists right there on the world's most popular developer platform.
That just seems incredibly bold. I mean, why would they use a public site like that?
It's what we call living off the land, using legitimate infrastructure to hide malicious activity. If you're a network admin, traffic to GitHub looks normal.
Right.
You see your server talking to GitHub, you think, oh, a developer is updating some code. You wouldn't block it. It allows them to just blend in with the noise.
That is clever. Devious, but clever. So scanner.py finds new victims. Then we've got kube.py. Based on the name, I'm guessing this is the Kubernetes specialist.
Correct. If proxy.sh realizes it's in a Kubernetes environment, kube.py takes over. Now, this is the one that keeps security engineers up at night. It harvests credentials and discovers pods, which are groups of containers, but then it does something called lateral movement.
Spreading sideways.
Yes. It drops proxy.sh into other accessible pods in the same cluster. So it spreads the infection deeper into the organization, and then it creates a privileged pod on every single node.
Privileged in this context sounds very important.
It means root access. It mounts the host file system. Essentially, it breaks out of the container and takes total control of the underlying physical server. It's digging a tunnel from the rented room straight into the landlord's bedroom.
And once they have that level of control, they can do anything. I see mentions of React.py and PCPcat.py here as well.
Yeah, React.py is the laser-guided missile for that CVSS 10.0 vulnerability we mentioned. It just executes remote commands at scale. And PCPcat.py scans for huge ranges of IPs to deploy malicious containers. It's a full suite. Every script has a specific job in the assembly line. Find, assess, infect, entrench.
And all of this reports back to headquarters, I assume.
To the command and control node, C2.
Mm-hmm.
The report identified a specific IP 67.21a.57.240. And interestingly, it's using the Sliver framework.
I've heard of Sliver. Isn't that a tool for the good guys?
It is. Sliver is an open-source framework designed for red teaming. That's security professionals who simulate attacks to test defenses. But like a hammer, it can build a house or break a window. Cybercriminals love tools like Sliver and Cobalt Strike because they are powerful, they're free, and they're well-maintained. Why build your own command center when you can download a professional-grade one for free?
It all circles back to that industrialization theme. They're using GitHub, they're using Sliver, they're using the community's own tools against itself. But the big question is why? We know they install crypto miners Lino or Esha is part of the toolkit. But is that it? Just stealing electricity to mine, I don't know, Dogecoin?
Well, if it were just mining, it would be annoying, but, manageable. Your bill goes up, your server gets slow. But TeamPCP has adopted a hybrid criminal model. This is the real so what of the episode. They realize that if you already own the server, why only monetize it one way?
Diversify the revenue stream.
Exactly. They have two main prongs. Prong one is what we've discussed. Compute theft. They use your hardware to mine crypto, yes. But they also use your server to host their own data or as a proxy relay. They'll sell access to your server to other criminals who need a clean IP address to launch their own attacks.
So my server becomes a hideout for someone else. Okay, that's prong one. What's prong two?
Prong two is data theft and extortion. So while that miner is running in the background, they are also exfiltrating data. They steal CB databases, identity records, corporate secrets, whatever they can find.
And then they hold it for ransom?
Or they just threaten to leak it. The report mentions they published this stolen data on a platform called ShellForce.
Is that like a dark website?
It's a Telegram channel and a leak site.
Yeah.
And here is the really twisted part. They do this to build reputation.
Reputation? Why do criminals need a Yelp rating?
In the cybercrime economy, trust is currency. If you are selling stolen data, the buyers need to know it's real. If you're extorting a company, the company needs to believe you actually have the data and you're capable of leaking it. By publicly dumping data on ShellForce, TeamPCP is basically saying, look at what we can do. We are serious.
It's branding. They're building the TeamPCP brand.
They are. And this hybrid model makes them incredibly resilient. I mean, think about it from a business perspective. Crypto markets are volatile. If Bitcoin crashes tomorrow, their mining revenue drops. But extortion is always profitable.
And if a company has good backups and just refuses to pay the ransom?
Then TeamPCP just keeps using the server for mining and proxying. They win either way. They have hedged their bets perfectly.
It's almost impressive if it wasn't so destructive. You mentioned a quote from the researcher, Asaf Marag from Flare.
Yes. He said, the danger here is not technical novelty, but their operational integration and scale.
Operational integration. That's the phrase that really sticks with me. It sounds like they've taken the principles of DevOps, automation, continuous integration, scaling, and applied them to theft.
That is exactly what has happened. We used to worry about the lone wolf hacker. Now we are facing an automated factory. The malware lands, it checks the environment, it swaps its tools, installs backdoors, starts mining, and steals data all within minutes without a human ever lifting a finger.
It effectively turns the biggest strength of the cloud against us. We built the cloud to be scalable and interconnected.
And the worm uses that very connectivity to spread and that scalability to mine faster.
So for the person listening to this, maybe they're an IT manager or maybe they just run a small server for a side project. What is the takeaway here? Because this feels like a tsunami you can't really stop.
You can't stop the tsunami, but you can definitely close the windows. Since TeamPCP is opportunistic, they are looking for the low-hanging fruit.
They want the unlocked doors.
Right. So the takeaway is basic hygiene, but taken very, very seriously. Lock down your Docker APIs. Do not expose them to the public internet. Secure your Kubernetes clusters with strong authentication. And for the love of everything holy, patch your frameworks. That React vulnerability, CVE 2025-55182, needs to be patched yesterday.
It sounds like the advice is just, don't be the slowest gazelle.
In this case, yes. If you reduce your attack surface, the worm will just bounce off and move to the next IP address. But if you leave those APIs exposed, you are volunteering to be part of their resource pool.
You become a battery in their matrix.
Precisely. And remember, this affects everyone, even who aren't hacked. This activity consumes massive amounts of energy and bandwidth. It drives up the cost of cloud services for everybody and degrades the performance of the internet infrastructure we all rely on. It's an unseen tax on the digital economy.
That's a really sobering thought. The cloud isn't some magical infinite resource. It's physical servers, and right now there is a war for control over them.
A war fought with scripts and automation.
You know, that brings me to a bit of a provocative thought to wrap things up here. We've spent this whole time talking about how the bad guys are using automation. They are essentially deploying a bad patch that updates our systems to serve them.
That's one way to frame it, yeah.
So if TeamPCP can scan the whole internet in minutes and exploit these holes using autonomous worms, does the future of cybersecurity rely on us releasing defensive worms?
That is a very aggressive concept.
Well, hear me out. A worm that spreads through the internet finds those exposed Docker APIs, but instead of installing a crypto miner, it applies the security patch, locks the door, and then deletes itself.
The benevolent worm theory. It's a technical possibility, certainly. If the attackers are moving at machine speed, our defense might eventually have to match that velocity. We can't wait for a human admin to wake up on Monday morning to apply a patch if the attack happened on Sunday night.
Exactly. It feels like we are bringing a knife to a nuclear fight. If they are automated, maybe our defense needs to be just as aggressive and autonomous.
It opens up a lot of risks regarding system stability. I mean, what if the good worm breaks the server? But you're right about the necessity for speed. The status quo of manual patching just isn't working against industrialized threats like TeamPCP.
Something to think about while you double-check your firewalls tonight.
Indeed. Check your APIs, everyone.
Thanks for diving in with us. Stay safe out there.